Good evening. My name is Bilal Adams, and I will be presenting to you on the topic of Android mobile application testing. First off, I just want to give some background on why I decided to pursue this topic. Currently, I work for a mobile software firm where we have about 4 or 5 products. I currently work with our main product, Deliver It. Um, with this product, it does contain 2 components, which is a mobile app as well as a web portal. The two communicate with each other. I'm not going to go in much detail about what our product actually does, but our mobile application does come in iOS as well as Android platform. Like I said, I chose to do this because I've noticed working in support for our application that we often get some bugs reported, which is normal. You're going to have issues from time to time. And I've noticed that it seems that when a issue is reported and I escalate it to a developer to fix it, that once they fix it, sometimes another issue is created, which led me to believe that, maybe we should spend a little more time doing regression testing after we make these changes. Like I said, it happens quite often. So I thought that this would be a great topic to present on since I actually am faced with these issues on a day to day basis. All right, so let's go ahead and get started. Okay. So, for those of you who are not really familiar with mobile devices, which I'm sure is not plenty, as we all have some type of mobile device, whether it's a cell phone, which I'm sure we all have, or a tablet. So, currently, right about now, there's about 3 billion users who are using some type of mobile device. Like I said, whether it's an iPad, some type of Android tablet, or your phone. Um, the issue is that a lot of times these mobile applications or mobile sites often lack quality. The reason that they sometimes lack quality is because they're pretty a lot of times they're built at a very fast pace, and with that being said, sometimes a lot of the testing is kind of skipped or it's not really focused on as much as they're really just trying to throw it out there and get it available for people to use. So as you can see, with this um, rate at the applications or sites or things are mobilized, if they're not being tested properly, you're can guarantee that you're going to see some issues and the quality will be poor. All right. Now, as I said, this presentation is specifically we're going to focus on Android mobile application. For those who are not familiar with the Android platform, I'll just give you a quick little background. So, to get started, Android is a software stack for mobile devices that include a Linux based operating system. The platform is used by developers to develop their own applications, and that is usually done in the Java program language, which is a pretty wide known language, pretty useful, pretty powerful. Um, so now I'm just going to go into, just kind of the breakdown of what a Android application contains. So the Android application is pretty much just composed of different types of components. One of the main components that is made up is an activity, and a Android application is usually made up of more than one activity. Now, it can have one activity, but that's pretty much your super duper basic activities. A best way to describe an activity is that you can relate it to a interface or a screen in a application. So let's say the first screen comes up, which is a login screen. So when developing your application, you will have a login activity. After hitting the login button and submitting your credentials, it would then take you to another activity class, which may display your account information. So in that just simple basic example I gave you, that would be possibly two activities. Now in your activities, the activities are composed of different. Let me see how can I put this. They are composed of different framework classes, such as views. A view is, a views, widgets, and dialogues. These are all these three things: views, view groups, widgets, menus, and dialogues make up a GUI interface so that the user can now interact with your app. So just some views would be a edit text view, a just a view just displaying text, buttons. All these things are views. Menus, you might have a app that has menus in it to select different options, as well as dialogues. As we all know, dialogues are pretty popular in all type across all applications. Dialogues are pretty much like pop-ups to get you to perform some type of action. So let's say you're going to make some type of change. A dialogue may pop up and say, hey, are you sure you want to do this? And it would then display you with the option to click yes or no. Okay. So that's pretty much a small little background just on how an application is put together. Next, I'll just go into the life cycle stages of an application. So an application on Android pretty much has three main states. The application is either running, which is it's in your foreground, you're using it. It's paused, which means you might have switched to another app, so now that other app is in the foreground, and now the previous app is now considered in a pause state. And then stopped would be when the application is not running at all, so you've killed the app. Now, as you'll know, in Android applications, the processing that happens for these applications is event driven, meaning all of the events and things that take place, there's some type of event tied to it. Now there are two types of main events. So pretty much you have your user driven events. So these are events that are driven by the user. So a user clicks a button or he mouses over on something, then that would be a user driven event. The other type of event that we're going to discuss is an external input driven event. So these are events that are driven by things such as like the GPS in your phone, location services, your network, things of this sort. So this is events that are at a certain event might happen when you get into a certain location. So that would be considered an external input driven event. Okay. So next, let's go to our next slide, and we're just going to discuss some of the open issues that we have on the Android platform when testing applications. Okay. So now that I've given you like a small, quick run around on the background of how Android applications are built, we're just going to go over a few open issues. So just like other EDS applications. Again, EDS is event-driven software. There are already several testing approaches available, but those techniques may not, suit Android application testing. Simply just based on because on the different type of user inputs. There's like various ways that you can input information in an Android application. You can type it, you can take a picture, you can scan in a barcode. There's endless ways of how to input information. So we're still faced with the task of finding out which technique is the most effective, which one is going to, going to test our application thoroughly. But at the same time, we also want to make sure that it's cost effective. Now, it should also be mentioned that in the other EDS techniques, they're all pretty much based on well-known models such as an event flow graph or a event interaction graph. Now, to use these certain techniques for the Android platform, we would then have to adapt these models and strategies, but we would still need to tweak it to fit the Android platform. Okay, so those are just a few open issues with Android mobile application testing. So we're going to go ahead and go to our next slide. Now we have this technique that's called the GUI crawler technique. So this is a solution to our problem with Android mobile application testing. And in this specific technique, it happens to just cater to Android applications specifically, and it happens to do a pretty good job. Now, in the GUI crawler technique, to solve these issues, what we do is, in this technique, a GUI crawler is used to simulate real user events. So by simulating these events, is equivalent to someone actually picking up the phone and clicking this button or tapping this button or scanning this or taking a picture of this. So it's actually simulating these real user events without a human having to do this, automating it and making this all faster. Not only is it simulating these real user events, it then produces a model based on the GUI of the application. Now, as we discussed in the previous, one of the open issues was that the other EDS techniques were based upon pretty well-known models that didn't really coincide with the Android platform. So in this GUI crawler technique, what it does, it generates a model for us automatically. Now, in this model, it's a GUI tree. So in this model, we have interfaces. So interfaces pretty much correlate to an activity or a screen. And we have transitions. So our transitions would be events. So in our GUI tree, we have interfaces as well as the transition events that'll show the correlation and connection between the different interfaces. So I click a button on interface 1, and then we would have a branch or a tree to the next interface, and that would be our transition. And I'm going to I have a slide actually a little further down the line that displays a picture of this so you can see a sample model. Now, the third and final thing in this technique that it actually does is it actually generates our test cases for us. So it actually generates the test cases off the model that was created. And with these test cases, we can, put together a sequence of events to automate crash testing, as well as if we make any changes, we can also go into some regression testing, which is very, very important. Like I said, I've dealt with this daily where a developer makes a change, he fixes that issue, everyone gives it the go-ahead, we submit it to the store, but we did no regression testing. So now the issue that he fixed, we've actually created another issue. So like I said, regression testing is really important, and we must always do this. Okay? So there's actually a tool for the GUI crawler technique, and it's called the Android Automatic Testing Tool. Pretty generic name, but it gets the point across. So in the Android Automatic Testing Tool, it contains three different components: the Java code instrumentation component, the GUI crawler component, and the test case, generator. Now, the Java code instrumentation component is responsible for instrumenting the Java code automatically. So in order to allow Java crashes to be detected at runtime, it allows us to pretty much manipulate the code so we can automate these crashes and see where they're at. Now, in our GUI crawler component, it's responsible for executing the Android crawling process proposed, and it produces a repository describing the obtained GUI tree. Now, not only does it create this model, it also extracts information about the running activity and the event handlers that the activity implements. In our test case generator component, it's responsible, it's pretty self-explanatory, for the abstraction of executable test cases supporting crash testing and regression testing from the GUI tree produced by the GUI crawler component. So this tool implements the GUI crawler technique that we just discussed with these three components: the Java code instrumentation, which allows us to manipulate code so we can automate any crash tests we want; the GUI crawler, which executes the application and creates the model as well as gets information about the interfaces and events; and then the test case generator, where it executes after creating the model. It then creates some test cases by sequencing the events, which will allow us to do some crash testing as well as regression testing. All right. So now let's look at a quick example of how this technique and tool would work. So on my next slide here, so let's just try to picture a calculator example. So in our calculator, the calculator is a simple mathematic calculator that can operate either in a basic mode, and in this basic mode, it will provide the possibility of executing, the basic arithmetic operations between numeric input values, or in a scientific mode, provide trigonometric functions, inverse trigonometric functions, and other ones. So we have this calculator pretty much that has two modes. Now, one mode is just a regular mode. It performs, addition, subtraction, multiplication. And then we have our scientific mode that performs trigonometric functions and things. So we use our Android automated testing tool, and it executes our application. Now, in our application, like I said previously, it creates a model, and in this model, we get interfaces as well as transitions, which are our events. Now, in this particular example, the calculator, after this application was ran through the Android automated testing tool, there were 19 events triggered, 19 interfaces, which you can kind of see right here, and I'm going to go to that slide next. You'll see one exception occurred, causing an application crash, and then You'll also see 17 test cases generated, and these 17 test cases generated are due to the 17 paths that are available for execution of this app. So let's just go ahead and look at the model that it created. So you can see here on this model, so if you see these top nodes, each of these little boxes or screens, these are interfaces, which are just pretty much screens in our application. You'll see here these arrows or node, these arrows coming off of the node, the screen, and these are our transition. These are events. So if you see here, this is our main screen here, I1, interface 1. This is just our main screen, and that is the normal calculator setup arithmetic screen. As you can see, if you click the scientific button, it then takes you to this node. And on the scientific node, of course, you have different options. So this is where you can click the square root button, cosine button, all the scientific calculation that you need. And as you'll see here, for the top node, which is just the regular the arithmetic screen, you'll see just the regular buttons, such as click on the plus button, the minus button, the multiplication button, the multiply button, or the division button. And as you can see, when you click one, it launches a new node, which is a new screen. So this is just an example of how the model GUI works. And actually, if you see here, it also, you'll see here from clicking the event 18, which is clicking on the 18 button, it produces a crash. So you can also see here an application where, okay, I click this certain function and my application crashed, which would now allow you to go back into the code and see specifically where it crashed, and you can analyze and fix from there. Not only does this model provide a good, graphical representation of like the flow of the application, this is where you can also simply create test cases by simply looking at your events here. So from I1 to I5 is a simple test case. Simple test case is click the multiplication button. So as you can see here, the GUI crawler technique is quite useful as it allows us to create and generate test cases. It allows us to identify crashes, and along with those test cases, it allows us to, perform crash testing as well as some regression testing, which is really, really important. Okay. So just to conclude this presentation, what we discussed is the use of mobile applications or sites are very, very widely used, and at times they lack a lot of quality because at the speed they are developed, and a lot of people do not put the proper effort into actually testing these applications, which of course leads to poor quality. Now, a lot of people skip this, skip testing because it can't be automated. They don't have the time. So by automating some of this testing by using techniques like the GUI crawler technique, we can drastically improve Android mobile application testing. Now, as mobile applications become more and more complex, the more, of course, we'll need to test. So this technique is a really good technique to follow for testing Android mobile applications specifically, as it allows us to generate test cases, and from those test cases, we're able to test, whether it's crash testing or regression testing. Thank you for your time this evening, and that was my presentation on Android mobile application testing. And just a reminder, don't forget to always do regression testing. Thanks.